All right, so this is on personal consumption. So the amount spent on food by an average American in his or her 20s with X thousand dollars net income can be modeled as N of X equals negative 0.35 plus 2.52 ln X $100 on the amount spent on housing as HX equals 0.58x minus $0.84 thousand. Now, we're supposed to use the output values corresponding to 2000 and 12,000 net income to determine the appropriate model for net income as a function of housing expenditure. Now, the italicized part in the book is wrong. To make it do the inverse model, which is what this section says we're doing, it had model the housing expenditure on net income, which is exactly what we would get out as input and output. It wouldn't change anything. But if we switch the income and housing, that would make it so it would work. And then write a model given the amount spent on food as a function of the amount spent on housing, and then how much is spent on food by somebody who spends 2,500 on housing, and at what rate is this amount changing. Then write it in sentence of interpretation for those two items. All right, so let's work through these. So for A, what they want us to do, use the output values corresponding to 2000 and 12,000. Now, notice the X is in thousands of dollars. So really, we want to have X is equal to 2 and X equals 12. So that's a key, making sure the units here match with the units that you're going to input. And so now for housing, then that's going to be the second equation. So we're going to have h of 2 equals 0.58 times 2 minus 0.84 thousand dollars, and h of 12 equals 0.58 times 12 minus 0.84 thousand dollars. Okay, so let's go plug those in and see what we get for our values. So let's clear that. So we had the 0.58 times 2 minus 0.84, and so we get 0.32. And then if we do it for 12, then we get 6.12. All right, so I think I can remember that. So 0.32 and 6.12. Again, $1,000, okay? Now, if we were supposed to use the output to determine the other way, so then what happens is our output becomes the input in a new function. And so our new function is going to use the point 0.32 comma 2 and 6.12 comma 12. So now we need to find that. Now, if we think about that, with those 2 points, we could get a line. And so that's what we're going to do. We're going to find an equation of a line. And I'm just going to cheat and just quickly do it this way. And I don't have to worry about anything. So I have 0.32, 6.12. And then over here, I had the 2 and 12. And I want a linear, so it's number 4, 1, 2. And so that's going to be my functions. So 1.724 and 1.448. So when I get that out, then I guess since originally I had h of x, it's now going to be x of h, and that was going to be 1.724 h plus 1.448, and that's going to be again $1,000. Okay. So that is the key thing here. The way they had it set up, it wasn't worded right, and so you weren't going to get this and find the inverse of this one here. So why we need that is because we can't plug those two equations or functions together because they're both in terms of x, so we couldn't do that. But if we took the inverse of this one, then we get the x of h, and then that x can be plugged in up here, which is what we're supposed to kind of do for part B here. All right, so so $1,000, and so do we need to be? Yeah, I think that's good. I mean, we understand that it's going to be the net in. It gives us the net income of an average American in his or her 20s, uh, based on spending, H dollars for rent or housing or whatever. Okay, so Then what we're supposed to do is we're supposed to find the food based on the cost there. So n of x of h. And then what we do is, so we plug in our x of h into the n. So kind of like I said, we're going to plug this into here. And so we're using this equation plugged into up here. And so when we do that, we get the negative 0.35 plus 2.52. Then we had ln, and then that was 1.724h, and plus 1.448. And this was in $100. Okay. And does it have anything else? I just model. Okay, now how much is spent on food by somebody who spends $2,500 on housing, and then what rate is this changing? All right, so that's when we actually have to do some more work. And so now we want on C, we want n of x. Now remember, we have to put this in terms of thousands, so this is going to be 2.5. And so then we just have negative 0.35 plus 2.52 ln of 1.724 times 2.5, and then plus 1.448. And that gives us, let's go check that out. All right, so negative 0.35 plus 2.52 ln of 1.724 times 2.5 plus 1.448. And I think that was everything. So we get 4.0615. Let's go out that far. And the reason why I think that, because it's in hundreds of dollars. So if we move 2 over, then to get the cents, we should probably have that. So 40615. So that gives us 4.0615 $100. Okay, so that was pretty easy. Now the next part, we want to take the derivative of this. So we want dn dh. Again, you take the first and the last and put that over, and then you see if you can get there from there. So we're going to have to take dn, and n is going to be with respect to x, so that's dn dx. Then we need to take dx dh, because x and h go together. And when we do that, that'll give us dn dh. And so now we need to find the derivative of n and the derivative of x. So let's go back up here. And so we're going to have to take the derivative of this, and we're going to have to take the derivative of that. So when we do the derivative of n, that just gives us 2.52 over x, because what happens is ln of x is 1 over x, and that's just a constant times it, so that gives us that. Now the dx over dh, that's going to be given us multiply by. Now we're just taking the derivative of this, so that's just going to be 1.724. Okay. Now, so we could go ahead and multiply that out. So if we multiply that, I'm just going to do that by hand calculator here. 2.52 times 1.724, and we get 4.34448 over x. But now we notice that that's an x and we want an h. So we have to plug in x here. So that is what x is. So now we just have 4.34448 over 1.724h plus 1.448. And so that is going to be, that's in, what's that going to be in $100. And that's going to be $100 per, and where was our thing here, $100 per $1,000 of housing. $1,000. Okay, so $100 per $1,000. And now we have to plug in 2.5 into that. So we want dn dh as h approaches, or equals, rather, not approaches. We're not doing approaches here. 2.5. So we plug that in, and so we have the 4.34448 over 1.724 times 2.5. Then that's plus 1.448. And if we do that, so we'll do that again just on hand calculator to get it quick. 1.724 times 2.5 plus 1.448. And we get 0.7545 $100 per $1,000. Okay. Now it says we need to write a sentence of that. And so I'm going to say we had it, what was the average American in his her 20s who spends 2,500 on housing, spends uh, let's see, what was that number? 406.15. So it's going to spend 406.15 dollars because I converted it from hundreds to, I moved to decimal place, so it's $406.15 on food, and that amount is, it's increasing, and by, now that's hundreds of dollars too, so $75.45 per $1,000 spent on housing. Okay, and that should give us the full answer on what they needed here. All right, so that's all I have for this section.